Ladies and gentlemen, good morning. Welcome back to our class. At least those of you who are present here survived all these festivities of the last 2 weeks, which is very good. So we go back to work now in the new year. I wish you all the best for this new year. Some of you will finish your studies here in Germany, and I wish you the best possible grades. Okay, I started in the last session with systematicity theory, which is supposed to be a general theory about what science is. The need for this theory is mainly due to the fact that the classical characterization of science by means of a scientific method doesn't seem to work. I told you that historical investigations into science have shown that for every candidate you propose as a candidate for the scientific method, you find counterexamples in the history of science. Counterexamples meaning that we can show that there are episodes of successful science. Everyone agrees that it's successful science, but nevertheless, this success was not achieved by following any particular method, but just by breaking it. The point is simply that the historical process of science is so complex. There are so many unforeseen situations such that it is impossible to give rules to be followed precisely and strictly. That's the whole reason. Science is a historical process, and this historical process has so many different aspects and is so complicated that it's impossible to give you a rule before knowing any particular situation that tells you exactly what is right to do. That's different from cooking. When you cook and you have the same ingredients, more or less the same ingredients, you can get rigid rules what to do with these ingredients, right? But in a historical process, also in political processes, by the way, it's rather the same situation. The situation in which you find yourself in and in which you want to do something and achieve something, these situations are so different from each other that it is just not possible to devise rules beforehand that give you the best strategy how to cope with the situation at hand. That's basically the thought behind that, and that seems to me quite plausible because as in politics, in science, when we discover something completely new, the whole situation about science changes. And if I am supposed to give you rules how to behave, say, in 50 years in some particular field, these rules may be completely dated in 50 years because some new knowledge has been gained in the meantime that tells you that in that particular situation to be coming in 50 years, you should behave very differently from what I can now anticipate for the situation in 50 years. So it's really a deeply historical process, and historical processes of that sort cannot be fully anticipated. And that is the main reason why we cannot anticipate how to deal best in a particular situation in science. What is required if I am supposed to give you the scientific method in form of a set of binding rules, of strict rules to be obeyed. So the strictness of these rules, or the strictness of the supposed scientific method, is undermined by the historical process, which is so that cannot be anticipated, such that the rules may be then not helpful for gaining knowledge, but they may be a hindrance. They may be blocking scientific progress, and that has been demonstrated, in fact, in the history of science, that none of these proposed scientific methods, or the scientific method, is really apt to deal with any situation that may arise in science. So, the result is that the classical characterization of science by means of a scientific method that has been around for 350 years or so, and which has been very plausible, and for most scientists also has been their self-image of science, right? You do science by following the scientific method. This image seems to be false. And the result then is that we don't really know how to characterize science if we can't characterize it by means of a scientific method. And systematicity theory, which is in fact a generalization of the idea of a scientific method, and I will show you why it is a generalization, that the systematicity theory has the sort of flexibility that is required from the failure, or from the insight into the failure of the characterization of science by means of a scientific method. And that's the basic idea then of systematicity theory. We have to come up with something new that replaces the idea of a scientific method in order to characterize science in its total breadth, including, that's what I said, including the humanities and the social sciences, not just the natural sciences. So the word science is a little misleading, and one should rather use the term research field. Everything that's a research field that's taught at some university, that is typically subsumed here under the title of science. But as I said, it's rather the German word Wissenschaft that covers everything, and it's not the word science, because the English word science typically covers the natural sciences and perhaps the social sciences, but not the humanities. But the humanities are included here. So that's the basic idea, or the basic, not really the basic idea, but the basic aim, the function that systematicity theory should play. Now, I gave you the main thesis of systematicity theory, or the fundamental thesis of systematicity theory. You see it here, and that says that scientific knowledge differs from other kinds of knowledge, from everyday knowledge in particular, primarily by being more systematic, and that already tells you that the contrast from which systematicity theory is working is the contrast to everyday knowledge. And that's different from the way the problem of what science is was tackled in the 20th century, especially in deductivism, when I told you deductivism tries to demarcate science from pseudoscience and from metaphysics by saying, look, the contrast we are looking at when we ask the question, what is science, in deductivism, is what's the difference between pseudoscience and real science, right? Or metaphysics and real science. And the contrast we are choosing here is a different one. The contrast here is that I say, what distinguishes science from other forms of knowledge? Acknowledged knowledge, real knowledge, like everyday knowledge. But what's the difference here? And the difference, that is the main thesis here, the fundamental thesis of systematicity theory, is a higher degree of systematicity, or more systematicity regarding scientific knowledge. Now, this thesis looks rather harmless. You think you can memorize it, and it's one sentence, and it's very simple. But if you look at it then more closely, you will see that it is quite complicated. There are intricacies in here, and I'm going to develop that. And the first, what I did is I made a few remarks, and the first remark was that the thesis is comparative in character, and that says that the other kinds of knowledge, scientific knowledge is compared with, are not necessarily unsystematic. They are just less systematic. And the example I gave you was that if you count the number of students in this room, for instance, you can also count the number of professors in this room, and it's also a systematic procedure. Namely, it's systematic the way we count, and many other things are not entirely unsystematic. So the claim is that scientific knowledge is just more systematic than these less systematic forms of knowledge. But one has to be careful. This more systematic refers to knowledge about the same domain. And I think the example I gave you here, for instance, is everyday knowledge about the weather, or psychological knowledge about people. And the example I developed a little was the assessment center, when you, in a scientific way, try to determine what sort of person someone is, when you compare that with the same subject matter, namely you meet some you haven't seen before, and then you try to figure out what sort of person he or she is. And what you do there is, of course, you gain knowledge. Well, it may be insecure, but that's also the case here in science. You gain knowledge about this person, but you do it in everyday life in a very different way than people do it in assessment centers, where they run a battery of tests in a very systematic way. They investigate, or it's the result of scientific investigations, how to run this battery of tests in the best way, what the best order is, whether you first go for motivation, and then for intelligence, and then for whatever it is that you want to know. Whereas in everyday knowledge, you don't have a fixed order, or at least you are not aware what you're really doing. The best situation, I always keep telling, just imagine the first day of the semester and you go to class, you've never seen the professor, and then of course you want to know who is that, right? And then the first 30 seconds, the first minute, is very thrilling. I mean, it happens to me also all the time when I go to some sort of lecture and a scientist, a philosopher gives a lecture whom I don't know. Of course you want to have a feeling, who is that? You know, what sort of person is that? Is he or she knowledgeable? Is she intelligent? Does she give me the impression of knowing her subject matter? And so on and so forth. And when you look at yourself and you think back of these situations, I mean, you're really trying very hard to find out who that person is. But you do it entirely unsystematically. You don't even know what you're doing because you're doing it somehow automatically, right? You just sit there and watch, and then you can afterwards, you can make yourself aware what you looked at first. I mean, some people then look at their hands, at their eyes, whatever it is. So people do very different things in order to find out who someone is. But as I said, when you compare that with the scientific procedures, then what really is very obvious is the much more systematic character of that gaining of psychological knowledge in a scientific context in comparison with the everyday context. So it's very important here that we have the same sort of domain or the same sort of subject matter to which systematicity theory refers. It says, when we have, or if we have, in a situation in which we have everyday knowledge and the scientific knowledge, then compare the two about the same subject matter, then compare the two, and then you will find out, that's the thesis here, that the scientific knowledge is just more systematic than the other form of knowledge. This is still repetition. And this is how far we got during the last session. Did any questions turn up in the meantime that you would like to ask? No, then I continue. And the continuation first says that the thesis seems to have a certain weakness. This thesis of systematicity theory. It seems to have, well, it does have that sort of weakness, if you wish. It has the weakness that this answer of what science is that systematicity gives, this answer is not immediately applicable to areas where only scientific knowledge exists, right? This is supposed to be an answer that covers all of scientific knowledge. Fine. It says scientific knowledge is more systematic than everyday knowledge. But there are areas where you cannot make the comparison, because the only knowledge that exists in certain areas is just scientific knowledge, and there isn't any everyday knowledge, right? Here's an example. Look, this is for the biologists among you. Look at the details of the gene expression process, right? Gene expression works according to current theory. You have the genetic information on the DNA, and then this information is translated is transcribed into RNA, and then it's translated, and so on and so forth. And in the end, we have a gene, we have a protein that is produced on the basis of the blueprint of the DNA. Right? This is a complicated process that has been within the last 55 years has been more or less thoroughly been understood. Now, this is certainly a part of scientific knowledge, there's no doubt. Of course, this is biology, it's molecular biology, biochemistry that is here involved in protein chemistry. that's involved, and this is undoubtedly scientific knowledge. Now, when you apply now the thesis of systematicity theory, you should be able to show that this is scientific knowledge by comparing this knowledge with everyday knowledge about gene expression, right? So what's the everyday knowledge about gene expression? Nothing, because gene expression isn't even a term in everyday knowledge, right? If you talk to someone who's not a biologist about gene expression, they say, what are you talking about? I don't know what you're talking about. So there is no everyday knowledge about gene expression, right? It just doesn't exist. And there are many other areas where simply is absolutely no everyday knowledge. The only knowledge that exists about gene expression is the knowledge of molecular biology. Right? There isn't any other form of knowledge about that. And of course, there are many other areas in science where you have the same sort of thing. So if you look at cosmology, for instance, about the Big Bang and black holes, for instance, there is simply absolutely no everyday knowledge about that. Of course, some people, everyday people, know something about that or believe something about it, but then only due to scientific knowledge. They read in Scientific American or in some journal, they read something about it, but it's scientific knowledge. So there are situations in which science is, so to speak, the only game in town to have any knowledge about certain areas. Now, the problem is that the problem for systematicity theory is that you cannot apply systematicity to these cases, systematicity theory, because you cannot compare it to anything, right? So systematicity theory has, so to speak, no answer whether that's scientific knowledge or not. It just cannot answer that. And that's, of course, a little awkward. And in these particular cases, the claim of systematicity theory is a little more complicated. One has to reformulate it or make it a little more sophisticated in order to apply it there. Now, and the proposal is the following. Let's assume we have a case now like gene expression, where we have only scientific knowledge, and then somehow the spirit of systematicity theory must be this knowledge is more systematic than everyday knowledge, but you cannot be applied immediately here because there is no everyday knowledge. But this spirit of systematicity can be realized in the following way. So first, go back in time until corresponding everyday knowledge in the respective area exists. So when you speak about gene expression, then we are in the area of genetics, and then gene expression, I mean, the structure of DNA was discovered in 1953 by Watson and Crick, and then the development of molecular biology started from then in a very rapid development. And I think that the fundamentals of gene expressions were certainly in the 50s or in the 60s, late 60s. This was more or less known. RNA was known then, and of course many more details had to be filled in, but the basic idea were in the 50s and 60s developed. Now, if you go now back in time, what genetics is, go back to Mendels' laws. And Mendels' laws were discovered in the late 19th century, so you go back 60, 70 years to the late 19th century, and then at that time Mendels' laws were the scientific story. But you could then compare Mendels' laws, the scientific stories, with the breeders' and farmers' knowledge. That is corresponding knowledge to Mendels' laws, corresponding knowledge of everyday people, right? Breeders and farmers. And you may know that Darwin, when he developed the theory of evolution, he used much of the breeders' and farmers' knowledge. He developed that further because he said that is how artificial selection functions. Breeders, what they do, they had artificial selection. That is what they simply do. That's the whole of breeding an animal or a plant in a way you want to have it. That was before the advent of molecular biology, of course, and biotechnology. So the breeders did artificial selection, and Darwin transferred this idea then to natural selection in order to develop his theory of evolution. Now, we can go back and compare then the scientific knowledge which is the forerunner, right, to these things here. That's a historical process. Out of that knowledge, Mendels' law and that stuff, then finally molecular biology developed, and then the theory of gene expression developed. But when you go back in time, you come to a situation where you can compare some knowledge, namely Mendels' laws, for instance, with breeders' and farmers' knowledge. And then what you are supposed to find here, that at this time, this earlier time, the scientific knowledge is more systematic than the other forms of knowledge. That's the thesis. You've got to find that out, right? If you don't find it out, it's bad for systematicity theory. But systematicity theory claims that if you go back in time and look then, say, Mendels' laws versus breeders' and farmers' knowledge, then Mendels' laws are more systematic than what the breeders and farmers know about their practices of breeding new animals, right? And then once you've done that, then you can say, okay, at that time, much earlier in history of science, the scientific knowledge was more systematic than the everyday knowledge. And then in the second step, you follow the development of that scientific knowledge, namely Mendels' laws and what you know there in the scientific area. You follow that into today's scientific knowledge, namely you go up from there, from Mendels' laws in 1900, 1890s, 1900, and you follow what happened in biology, right? And then you are entering areas where always scientific knowledge is the only game in town. But the point is then that from Mendels' laws on, you will see, that's the thesis of systematicity theory, that the systematicity of that scientific knowledge itself will increase, right? The point is systematicity theory not only claims when you compare scientific knowledge and corresponding non-scientific knowledge that the scientific knowledge is more systematic, it also tells you once you look at the dynamics of scientific knowledge itself, it also becomes more systematic, which is also fairly obvious, but I give you more examples later, right? So whenever you look at some area in science and you look 10 years later and 20 years later, the claim of systematicity theories, that knowledge has become more systematic, right? More details filled in, whatever more systematic means exactly, which I'm going to explain to you, right? So that is the idea, that this knowledge has then an increase of systematicity, and where you can compare, where you can still compare it with everyday knowledge, it's already more systematic. This one stays here, the farmer's knowledge stays the same, the everyday knowledge, but this one here becomes even more systematic, right? And although now today you cannot compare it to anything because there is nothing on this side concerning gene expression, it does make sense to say that scientific knowledge is more systematic than everyday knowledge. Although for these particular situations, for this one, it's not literally so, right? Because there is nothing you can compare it to. But the spirit of systematicity theory is conserved in this answer, namely that the essence, so to speak, of science is really systematicity. And systematicity is what makes science unique in comparison to other forms of knowledge. That's a little more complicated, the argument, but as I said, this argument preserves the spirit of systematicity theory by widening its application to these cases where it's not immediately applicable, and by adding the idea that also the internal development of scientific knowledge is one in which the degree of systematicity increases. Okay. This is a little complicated. You may forget it for the moment because, first of all, we have to understand systematicity theory itself a little better, and this is the last remark then before I develop systematicity theory further, and this is the remark that the answer that systematicity theory gives is primarily descriptive and not normative. You remember when we discussed the distinction between descriptive philosophy of science and normative philosophy of science, inductivism was a normative philosophy of science, as was deductivism, and then paradigm theory was a descriptive philosophy of science. The difference being, again to repeat that in normative philosophies of science, you try to think what a reasonable procedure should be for science, right? It should be what the norms are for reasonable procedures in science. Whereas in descriptive philosophy of science, you don't ask this normative question, what should be, but you simply ask what is the case, right? What is the case in real science, and you describe what is the case in a generalized way, not as a historian, but really as a philosopher in the sense of having a generalized description. And this is the case here as well, namely it is a philosophy that is a descriptive philosophy of science, and that means that once we have to give arguments why systematicity theory is a good theory, of course we must refer to existing science. We must go back and look whether real science is really more systematic than everyday knowledge, right? Because it's a descriptive theory. The claim of the theory is, if you look at real science, it is more systematic than everyday knowledge, right? It doesn't say anything how science should be, but it simply says, look, if you look at scientific knowledge, it is more systematic. So this has consequences, and I developed the consequence of this difference between descriptive and normative philosophies of science already a little, namely by saying that this difference becomes extremely important when it comes to giving reasons, to giving arguments for a certain thesis. Then it's very important whether a thesis is normative or whether it's descriptive. In the descriptive case, you have to refer to the things that are described and then show that the descriptive thesis is right, by comparing it to the things described. In the normative case, this is different. Okay. These are the preliminary remarks. That should give you the basic idea what the aim of systematicity theory is and what the main thesis of systematicity theory is. Has this become more or less clear? Are there any questions? Yeah? It's a little abstract still. It will become more concrete when I develop the theory more, but it's, I think, useful to have this abstract idea in mind before one goes into the details. Okay? No questions? Everything completely transparent? You feel like the author of systematicity theory yourself because you understand it so well? Okay. So let's continue. All right. But please interrupt me if you have any questions. All right. Now, systematicity theory is now a little more complicated. I already announced that when I gave you the fundamental thesis. It looks so very simple, but if one develops the theory, it becomes a little more complicated, which is, of course, not a big surprise because science is a complicated enterprise, and therefore an adequate theory about science will not be completely simple-minded. That's absolutely impossible. Because the thing itself is really complex and has many, many aspects. So systematicity theory has also some aspects, and the most important one, or the fundamental one to be developed now, is that systematicity theory does not only claim simply, homogeneously, look, science is more systematic than everyday knowledge. No, it's more specific by saying, look, this claim of systematicity theory does not apply just to science without any further specifications, but it applies to 9 different aspects of science that can be specified, right? It says not only, look, science is just more systematic, but it says, no. There are 9 aspects to which this thesis refers and to which it applies. And that's the following 9 aspects or dimensions of science. You see it immediately what I mean once you see this list of aspects. Now, the first aspect here is, now we go, descriptions. And that means the following. Systematicity theory claims that whenever you find descriptions in science, you find other things in science as well, but you also find descriptions, then the scientific descriptions will be more systematic than corresponding everyday descriptions, right? This is the descriptive aspect of science. Science does many things, for instance, descriptions. So the claim is descriptions are more systematic. Here's another one. Science also explains. We talked about explanation in science. Remember, in inductivism and deductivism, the derivation by the explanation by using a law and then certain conditions. We talked about that, and the claim here is also that systematicity theory makes is scientific explanation are more systematic than everyday explanations. Here's another one. Science also predicts. Not every science, but some sciences predict. Physics, astronomy. Remember the eclipse, solar eclipse. Yesterday's solar eclipse was predicted, of course, by scientific models. It was calculated on the basis of Newton's theory of gravitation, right? And some observations where the sun and the moon are, and then it was predicted. So science also makes predictions. Not every science makes predictions, but some sciences make predictions. And the claim is, again, that scientific predictions are more systematic than everyday knowledge predictions. Also in everyday knowledge we predict certain things, especially about human beings, about the weather. You not only listen to the weather forecast all the time, but sometimes you look out and say, oh, in an hour from now we will still have sun, right? Why do I say that? Well, the sky is so blue that in this country clouds don't develop that quickly as they do in some tropical countries where I would be insecure how to predict it. But in this particular case, I can predict we'll have still sun in an hour from now. You know, but just this is everyday knowledge about the weather. You can test it. What's the time now? Okay, 11:45. We'll still see the sun. This is an everyday knowledge, right? That's my everyday knowledge prediction about the weather. And of course, if you compare that with the prediction in a weather forecast, in a professional weather forecast, if you look at them, I did that, and they have very complicated models with millions of data points, which I evaluated in big computer programs, and with big modeling, global models, you have embedded and local models that give you much more detail, and it's very, 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 very complicated, and you use very fast computers for weather forecasting. It's routinely done, of course, in some stations in the world. There are not so many. And of course, almost every country has this local weather forecast. And it's, of course, much more systematic than anything I do, right? I look out, I see a few clouds there. I know these clouds develop very slowly, right? We have sun. There's nothing I can see on the horizon, you know, these big clouds that develop fairly quickly. And that's about it, you know, not very systematic. I mean, I just look out, is it day or night? Oh, it's day, good. Okay, very systematic, right? So it's just a few data I collect, and then I make the prediction. And when you compare that, of course, with the scientific predictions, it's quite obvious that they are much, much more systematic. So that's the third dimension here, predictions. Here's another one. I'm going to develop these 9 dimensions now in detail, right? I'm just giving you now the list of these 9 dimensions and develop them in detail. Just now that you get, again, you get the full picture, more abstract, and then I fill in more of the details. Here's another one, predictions. The next one is defense of knowledge claims. Now, also in everyday knowledge, of course, when you claim something, for instance, you claim, oh, look, Krista has a new girl, Krista has a new boyfriend. Do you know that? No, I don't know that Krista has a new boyfriend. How do you know? You know, I saw her holding hands yesterday at the Krupke, right? Holding hands, a guy, I hadn't seen him before. It must be her new. So you are, if someone asks you, how do you know, you have to defend it, right? And you defend your knowledge claim, and we do that, of course, in everyday knowledge, but also in science, of course, knowledge claims have to be defended, as you all know from your master's thesis, right? If you claim something, you have to defend it by means of data and blah, blah, blah. So whatever the details are, I'm coming back to these details. The point is that what systematicity theory claims here is that the defense of knowledge claims in science is just more systematic than the defense of knowledge claims in everyday knowledge. That's the theory here, systematicity theory. And again, if you just have a few examples in your mind, it's very plausible, but I give you more arguments for that later. So that's the defense of knowledge claims. Here's another one, an interesting one, which is possibly not immediately obvious to you. That's the thesis of critical discourse. What is talked about here is the fact that in many, at least in most occasions, when knowledge is at stake, we talk with other people. Right? It's not that I gain knowledge just for myself and then I don't talk to anyone, but I talk to other people. And typically, when it's about knowledge, then the talk of knowledge is a critical discourse, it's a critical conversation, right? Like the one I just gave you as a model of everyday defense of knowledge claims. When I claim Krista has a new boyfriend, right? Then I talk to someone and then this person asks me, how do you know? How did you find out? What's the indicator? Blah, blah, blah. So then we have a discussion about it. That's critical discourse. That's a social phenomenon, right? The claim of systematicity theory is that also the social phenomenon of science, namely the talking about knowledge claims, is in science more systematic than in everyday knowledge. We have that in everyday knowledge as well, as I told you, as I showed you with that hypothetical examples about Krista's new boyfriend. But in science, the same sort of critical, the same sort, yeah, roughly the same sort of critical discourse also happens, but the social form, you know, these social events and social processes of people critically discussing with each other, but that form, this social form in science, that's the claim, is more systematic than in everyday knowledge. That's the fifth dimension. Here's the next one, epistemic connectedness, and that's something which is probably completely opaque to you now. You don't know what I'm talking about here, epistemic connectedness. I'm going to explain that to you. That means something, the way different pieces of knowledge that you have, how these different pieces of knowledge are connected with each other, right? Some things, some pieces of knowledge that you have, or most of, or probably all of the pieces of knowledge that you have, are somehow connected with each other. So, for instance, let's go back to the example of Krista's new boyfriend. When you say, someone asks you, how do you know that she's got a new boyfriend? And then you answer, well, I saw her holding hands with a guy that I don't know at the Krapke yesterday. Then, of course, you have a connection to other things of knowledge, because then you know that, at least in this culture, and probably in your home culture as well, when a man and a woman standing there holding hands this way, perhaps a little closer, that means something, right? That's not an accident. It's not something without any social meaning. No, it does mean something. You only do that with people with either kids, right? Then there may be same sex or different sex. But if it's a person, the age may be even inappropriate. But if they stand there and hold hands, that means something. So this knowledge about Krista is, of course, connected with other pieces of knowledge, namely your knowledge of the culture here, that you know holding hands means something, typically, right? It depends on the time. If you hold hands just for 1 second and shake it like that, it means something else, right? But standing together, smiling and holding hands like that, that means something very different, right? And you know that. So when you defend your knowledge claim about Krista's new boyfriend, of course you refer to other pieces of knowledge, namely your knowledge of social, in this case, social institutions, right? It's a social institution that holding hands and standing close means something. It expresses something. It's something that these people share in this very moment. Okay, so also our everyday knowledge, we have connections to other pieces of knowledge. It's not disconnected. And the claim then of systematicity theory is that scientific knowledge has also epistemic connections, connections between pieces of knowledge. But in scientific knowledge, the epistemic connections between different pieces of knowledge are more systematic than in everyday knowledge. That's the claim, right? Also, the overall structure of knowledge that exists in the scientific case, this overall structure is characterized by a higher degree of systematicity, right, than in our everyday knowledge. So this is the sixth dimension, which is possibly a little new to you, but you will see once I give you more examples, or more detailed examples, that is quite a plausible thing. Then there's another thing which adds to the systematicity, or the higher degree of systematicity of science, is the idea of an ideal of completeness. in many cases, also in everyday knowledge, we have an implicit, not in all cases, but in many cases, we have an implicit idea that you want to know everything about something, right? For instance, as I said, let's go back to social relations, because they're always nice and funny, and they're very, very clear and plausible. You decide you want to marry someone, right? And then you say, well, if you marry someone, that's a rather grave decision, right? That has consequences, a lot of consequences. It may change your life more or less completely, right? So you better know whom you are marrying, right? At least in the Western ideal of marriage. In the Western ideal of the 20th or 21st century. There are other ideals of marriage where you say, well, money is the most important thing. So let's go to that case of the Western ideal, where romantic love is a very important ingredient in marriage, at least officially speaking, and in Hollywood movies, possibly also in Bollywood movies, at any rate. So romantic love is something very important. And that means then, if you want to marry someone, then you want to find out who that person is, and you want to know, well, in the ideal case, everything, right? That's at least the romantic idea. You want to know this person completely. So you try to find out everything about that person, whether she's a good person or a bad person, or a rich person or a poor person, what her parents are, and so on and so forth, right? So we also have sometimes in everyday knowledge ideals of completeness. When you compare that with scientific knowledge, then you find, that's the thesis here, and I'm going to give you arguments for that, that scientific knowledge has a more systematic idea of completeness, right? A more systematic ideal. In science, this idea of completeness is very systematically pursued. And I'm going to give you examples in order to justify this claim. That's at least here what systematicity theory claims, and that is the dimension number 7. Then here's the next dimension. As I said, I'm only giving you the list of these dimensions. I'm discussing every dimension in details in the second half of this session and in the next session. Knowledge generation. That is already what I hinted at with the example of getting to know a particular person. The way knowledge is generated is, in science, typically a more systematic process than it is in everyday knowledge. I gave you examples already about the predictions, how the knowledge about predictions is generated, and things like that. That's another aspect. Again, here it's very important to state explicitly that systematicity claims something comparative. It says the knowledge generation in science is typically more systematic than in everyday knowledge. That does not exclude the possibility that does exist in science, especially in fundamental science, that the knowledge generation process may be quite chaotic, right? May be quite disorderly. If you look at the larger scientific revolutions, you know, when people really don't know what they are doing, when no stone remains unturned, right? When everything falls apart, like in the quantum revolution, I talked about that between 1922 and 1925, when Bohr's model was out of steam, it didn't work any longer, and then people thought about a new quantum theory. If you look, the knowledge generation at that time, that was quite chaotic. It was quite strange. I think I gave you the example, or I may give it now, the example that someone came up to Niels Bohr at that time between 22 and 25 and said, look, Niels, I have a very crazy idea here how the new quantum theory might look like. And then Bohr replied, yes, that's a crazy idea, but it may not be crazy enough, right? That was a situation where people knew something completely crazy and strange will be the next step in science. And that was, of course, then not very systematic if you have to come up with more crazy ideas, right? With crazy ideas that solve the problem. So the process of knowledge generation may be, in some cases, quite chaotic. I hope that the knowledge generation process in your master thesis is not so chaotic, but it's rather orderly and systematic, because it's better for you, right? When you know what you're doing, and then you know this step, data collection. Next step, data analysis. Next step, comparison with my hypothesis, blah, blah, blah. You know, all this way, very orderly, very systematic. It's much better to do it that way, right? But sometimes in other episodes of science, typically not during master thesis, the process of knowledge generation may be quite chaotic, and that's also a part of science. And finally, here's the final dimension here, number 9, that the structure and the representation of knowledge in science is much, much more systematic than it is in everyday knowledge. I mean, in everyday knowledge, the representation of knowledge and the structure of knowledge is in your mind anyway, only. I mean, what you know, say, about social institutions, you don't have a booklet where you look at, you say, you stand at the Krupke, you see Krista is holding hands with a new guy, you say, what does that mean? And then you go to the manual, holding hands, holding with a different sex. Ah, that means romantic involvement. Ah, that's a case of, you don't do that way, right? Your everyday knowledge is somewhere stored in your brain, somehow. Nobody knows exactly how it is stored there. People in cognitive science investigate that. But when you compare that with the structure and representation of scientific knowledge you find, of course, explicitly in the handbooks, in the encyclopedias, in the textbooks, and so on and so forth, in review articles and whatnot. And what we will find out very quickly is, of course, that this representation of scientific knowledge is much more systematic than the representation of our everyday knowledge, right? Again, this will be very obvious, but I will give you more detailed examples. So, this was only the overview, right, of these 9 dimensions. Now you see that systematicity theory is not that simple, that it has just one single thesis by saying, look, science is more systematic than everyday knowledge. No. This applies to 9 different dimensions, and once you want to argue for systematicity theory, what I'm going to do after the break, I start this long argument, then you have to go through all these 9 dimensions, right, and show that science is indeed, for instance, more systematic with respect to descriptions. But that is what I do start after the break. See you in 10 minutes.